Okay, so we're recording, so thanks everyone for joining. I'm going to share my screen. All right, so before we get started and jump in, there are just a few things that I want to make sure everybody knows about. And this is kind of a review. It may be a review for some people, but others who may be new to searching in ORCID, this might be new information. So just so that we're all on the same page. What we're going to be talking about today is searching the ORCID registry, which is all of the ORCID IDs and their corresponding ORCID records that are out there. We're going to be searching that ORCID registry for information about who has an ORCID ID at your organization. This is one of the biggest questions that I get from people in the community, ORCID members. They want to know, for example, at University of Oregon, how many faculty already have an ORCID ID? How many students already have an ORCID ID? And the way to find that out is to do a search of the ORCID registry. Now, there are some caveats to searching. So what you're seeing right now is my ORCID record. I'm logged in. And when we do searches of the ORCID registry, we basically have search terms, and then we're looking for ORCID records that have information on there that matches the search term. So if I'm doing a search to find everyone that has lyricists in their employment section of their ORCID record, I'm only going to get results for people that have lyricists listed in their employment section. And if their information is set to everyone, which means it's publicly visible on the web. If somebody has lyricists on their ORCID record, but their data is set to trusted parties, or their data is set to only me, which means it's private, that person is not going to show up on my search. So just keep that in mind, that when we're doing these searches, the results that are coming back are only the people that have something on their ORCID record that matches that search term, and that information is set to public. So you might have a lot more people at your organization than what comes back in your search results, because you might have somebody that literally just has their ORCID ID, but no information on their ORCID record. That's really common when people have to create an ORCID ID in order to like apply for a grant or submit a paper. Sometimes they just register for that ORCID ID and they don't do anything to populate the rest of the information on their ORCID record. So there are, I think, quite a few people that just have the ORCID ID number and don't have any information. So those people aren't going to come up in your search. So that's really kind of the number one thing that you need to remember when we're doing this searching, is that you're not going to get a 100% accurate result. It's only going to show you the people that have this information publicly available on their ORCID record. But a lot of people, you'll be surprised, do have the information. So it's definitely worth looking into. The other thing that I want to just make sure everyone knows is that when we do get these search results back, this is really, the results are really just for kind of giving you an idea of current adoption levels at your organization. It should really just be used for like planning and assessment purposes, so you can get an idea of like how many people have an ORCID ID at your organization. But because there is still some room for error, maybe somebody has your organization listed, but maybe it got there by accident, or maybe they're listed as the most current employment. In other words, it says to present and there's no end date there, but maybe it says that on their ORCID record, but they actually have left your organization. So there are there's room for error. So you really should not take the ORCID IDs that you get back in the search and like import them into one of your local systems. There is a different way to get ORCID IDs into your local systems, and that is using the ORCID member API and what we call OAuth. That's a topic for a different call. But just know that these results that you get back in the search should really just be used for assessment and planning purposes. A couple of other things I have highlighted here, just to let you know, most of the people on this call are probably from ORCID member organizations, and that means that you have access to the ORCID member API. There's also a public ORCID API that literally anyone with an ORCID ID can use the public API. If you go into your ORCID record, there's a developer tools section, and that's where you can get some public API credentials. But just know that for the purposes of searching within ORCID, it really doesn't matter if you use the public API or the member API. When you're searching, you're only going to have access to the public data. The member API really only comes into play when you're using the OAuth process that I talked about, where you're actually having individual researchers connect their ORCID ID with your organization through a member API integration. So just know that there is a public API. You can use the public API to search the ORCID registry. You can use the member API to search the ORCID registry, but either way, you're only going to be getting results back where the data is set to public. Okay. The other thing that I wanted to point out before I will hand it over to Clark is throughout this search process, you will need, we have some basic search terms set up, which if you scroll a little bit further down on the notes document, you'll see that, within the R script, there are search terms that are indicated here. And so this is a very basic set of search terms. Some organizations might kind of fall outside of this if you have more than one name that your organization goes by, or if you have something called a fund ref ID. But the Ringgold ID and the GRID ID are really the two most common for universities. If you're not from a university, you might have a little bit of a different scenario. So if you do, I would just say contact me and we can work through your special scenario. So just to finish this thought, and then I'll address Sherry's question in the chat. For these search terms, of course, you know the email domain for your organization and you know the name of your organization, but what you might not know is the Ringgold ID and the GRID ID. So the Ringgold ID and the GRID ID are organizational identifiers. Ringgold is a proprietary identifier. GRID ID is open. Very soon, hopefully, we will all be moving to something called the Research Organization Registry, which is ROR, which is also open and it's based on GRID. But for the time being, we'll be looking at Ringgold and GRID. So you're going to need to find that information. So I'll tell you very quickly, for GRID, super easy. You can just search GRID ID. But basically, if you go to the grid.ac website and you click explore, which I can't, if you click explore, you can type in your institution's name, for example, and it will show you the GRID ID for your organization. So you can just copy that GRID ID, which starts with the word GRID, and then it has a series of numbers, and then a period, and then another number. So that's how to find your GRID ID, super easy. For Ringgold, because Ringgold is proprietary, you can search within Ringgold, but you have to register as a guest user before you do that. So if you go to ringgold.com, I can put this into the chat. Where's my chat? Okay, so you can register as a guest. If you don't want to do that, let me show you a really quick, easy workaround. So if you're logged into your ORCID record, which hopefully everybody has an ORCID record, you will need an ORCID record to do the searching in R. So I encourage everybody, if you don't have an ORCID ID, you can register for one very easily. Oh, it's taking a minute. Okay, I guess while that's loading, I'll look at the chat. Oh, good, John's here, and it looks like okay, so Sherry, if a person has the employment information with their settings set to trusted parties, the member API can read that information if that person has connected their ORCID ID with your local ORCID API integration through the OAuth process. If you're just searching within ORCID and you don't have that permission from people, information set to trusted parties only will not come back in a search. I know that is a little confusing potentially, but basically in order to read information that's set to trusted parties only, you need to have a local ORCID API integration using the member API, and that individual would have needed to go through that OAuth process to connect their ORCID ID with your local integration. But with searching, when you're just searching the ORCID registry to see what's out there, you are not going to get results that are set to trusted parties only. You are just going to get public results. I hope that answers your question. Okay, great. Okay, so this loaded. So let me just show you the workaround for getting your Ringgold ID and your Grid ID. So, and I do this all the time. You can also email me and I can look up your Ringgold ID for you. But if you go to for example, the Add Employment section, and you just start typing the name of your organization. And just a little hint, sometimes when you type the full name of the organization, you have to hit the space bar and then it'll show up. So see how this is showing up in the drop down? And then, so University of Oregon is here, but it's also appearing again here. That's because one of these entries is related to the Grid ID and one of them is related to the Ringgold ID. I'm going to take a guess and just click the first one, and that will pre-populate some of the information. Now, when I hit add to list, now it's on here. I'm going to click this little gray arrow, and you can see that the Ringgold ID is appearing. Okay, so this is the Ringgold ID for University of Oregon. So that's a workaround for getting your Ringgold ID. You can get the Grid ID the same way. I would have just had to select that second option in that drop down and it would have shown me the Grid ID. But because you can look Grid ID up easily online, Ringgold is really the main focus for this workaround here. So I do this all the time and then I just delete that entry because it's not actually my employment. I just wanted to get that Ringgold ID. So that's how I do it. Okay, I think that's all I was going to cover before we dive in. Are there any questions before we hand it over to Clark? And feel free to unmute as well. Yes, the Google Doc. I'm going to stop sharing. Okay, so I am so happy to introduce our colleague, Clark. And now, Clark, can you say your last name? Because I just want to make sure I'm saying it correctly.
Iakavakis.
Iakavakis. Iakavakis. Okay, cool. There are lots of ways I could have really messed that up. So
There's a
Clark
lot of ways
Iakavakis,
to say it,
I
and I
bet, yeah.
really want to.
So Clark is from Oklahoma State University, and he has graciously offered to share his knowledge of R and R ORCID with everyone on the call. So I'm gonna now let Clark take us through this R script demo.
All right, thanks so much, Sheila. Before I start, I am in one of those affected states. It was -9 when I woke up this morning. They've been threatening to do rolling blackouts to preserve energy. So if that happens, I've got my iPhone hotspot and I'll try and jump on if that's possible. But so hopefully I don't get cut off and this just lasts for the next hour or so. Yeah, thanks for attending here, everyone. I'm the Scholarly Services Librarian at Oklahoma State University. Um, I want to start off by saying that I'm not a computer sciences, statistics, programmer person at all. I have a humanities background in addition to my librarian background. And the reason I say that is because I think some people get intimidated by the idea of using R or using command line programming. And I'm kind of evidence that you don't have to be that, come from a computing background or a sciences background in order to integrate and use R in your daily work. So this session is going to get a little bit in the weeds. I'll tell you my goals here. One goal is if you don't really care to get in the weeds, you don't want to know R, you just want to get the data. I'm hoping that you can come away from this just being able to run the scripts and get the data. Okay, but I also want to talk about what it's doing. And so at times I'm going to get in a little bit detailed. This is not the ideal way of introducing someone to R by diving in the deep end, so to speak, and like getting into some pretty hairy functions. So I'm going to try and tread that middle ground. I hope that you don't drop off and say, you know, this is just too much for me. And as Sheila has graciously mentioned, if you do say, okay, this is just way too much, she can run the script for you and get the data for you. So with that said, I do want to talk a little bit about what R is. So I'll spend a few minutes setting that up and discussing R and discussing the RStudio interface before we get into running the scripts themselves. And I don't mind being interrupted, so feel free to unmute yourself and say, hang on a second, I have a question, or type into the chat. That is totally fine by me. Also want to point out, it is shared in the Google Doc, but a lot of this is already written out on my website at this link. And let me go ahead and share my screen here. And also, if you don't have R and you don't want to download R, you can click on Launch Binder here, and that will open up a Jupyter Notebook, which is basically within something called Binder, which will basically allow you to run the functions that we're going to discuss today without having to download R yourself, basically from directly in your browser. So that's an option for you. And of course, this is being recorded, but if you need to go back and kind of take a look at the script that was provided doesn't have any of this explanatory text, but this webpage does. So as you're going along, if you find that you need something explained in a little bit more detail, then come on back to this site for that. So also want to give a huge shout out to R OpenSci and specifically Scott Chamberlain. He and this organization, the ones that created the R ORCID package. They have a ton of really cool R packages, especially if you're involved in scholarly communications and librarianship. there's so much here that is like really worth digging into. Um, and they do all of this work as on a nonprofit basis. So all of the work they do is open and freely available, and just a huge benefit to our work in scholarly communications. All right, let me go ahead and switch over to R. So if you have opened up the R file, this is what you'll see over here on the upper left side. Let's talk a little bit about these panes briefly. This pane in the upper left is called the script pane. And this is, as the name implies, a place for you to write a script or open up a script and run the functions or the expressions within that script. So when you do run a line from the script pane, it will show up down here in the console pane. So for example, if I load the library of our ORCID, which I'll talk about what that means in a moment, if I run this, which I can do either by clicking the run button here, or I can press Control Enter. So if I'm on the line 20, and I press Control Enter, it will run that line, and you'll see it show up down here in the console pane. Over in the upper right is your environment pane. I have two objects that currently exist in my environment, and that is because I wanted to run these heavy API queries before I came on this call, so we're not sitting here and hoping that they'll run while we're watching my screen. So yours will probably be blank, and we'll talk a little bit more about what all of that means. And then in the bottom corner is your kind of navigation pane, where you have your files. If you run any visualizations, they'll show up here. If you install any external packages, which I'll talk about in a second, you can see those here. And also any help text you can see here as well. So what I'm going to do to highlight a little bit about R is I'm going to open up a new R script, and I'm going to do that by clicking on this little icon here and clicking on create a new R script. You can also press File, New File, and go to New R script if you want to create a blank script. And so R is basically, it does a lot. It's a calculator. It's an interface to APIs to pull in data from external systems. It's statistical analysis. You can write programs in R. You can use it to clean your data. You can use it to visualize data. It does a whole lot. It is command line. There are visual user interfaces for R, but we're going to focus on the command line, which means we're going to type out commands. We're going to, or expressions, you could also call them, and then evaluate those expressions. So as an example, I can press 2 + 2, and then I can press Control Enter. That 2 + 2 is an expression that is evaluated in the console, and you can see that it's 4. You can also type in functions in R. So for instance, I can take the sum of 2 + 2. Sum is a built-in function that kind of comes out of the box with R. And it does as you would expect. It sums the numbers inside the parentheses. So we can see the sum of 2 and 2 are 4. Functions, if you need to learn more about those, you can you press a question mark and then type the function name in. So if I do that, question mark sum, you can see in the bottom right-hand corner, it will give you a description of the help. So we're going to talk a little bit about this just because it is important for you to know how to read these help pages. What this is saying is it gives you an example of the usage. It tells you what the function does, and then it tells you what arguments it takes. In this case, sum can take these following arguments. It can take any set of numeric or complex or logical vectors, in other words, basically numbers. And then it takes this function, this argument NARM. So this is kind of issuing instructions for how to evaluate this expression. So for instance, if I was to sum 2, 2, and NA, which NA is a missing value, then it's going to give me NA because 2 plus 2 plus a missing value is a missing value. But you can add in to these parentheses the argument na.rm, which is a logical true or false. And that's saying when I evaluate this, should missing values be removed? So when I add that in, NARM equals true. Now, sorry, that's my
Smoke
smoke.
alarm?
My fire must be smoking. Once.
Okay, okay, no worries. It happens. We're live. We'll just wait. We'll just give him a minute. I had my smoke alarm do the beeping thing when it runs out of batteries. It seems like that always happens in the middle of the night when I'm trying to sleep, that little annoying beep every minute. Yep, I had to deal with that recently. It was fine, but it was just like, I was half asleep. So I was like, am I dreaming or is that an actual noise that's happening? Yep, I always have to get, yeah. Luckily I can reach mine if I get up on a chair, but for people that have really high ceilings, I don't know how you do it. I hope there's not an actual fire, Clark.
Wow, no, there's no fire, but my fire in the fireplace, I guess the connection.
Okay, okay. No worries, no worries. I'm glad you're okay.
Okay, sorry about that.
Carry on.
Alrighty, so the reason that I gave you that introduction is just so you can kind of see the basic outline for how R works and how it accepts functions. And it's important to read the help pages and know these different arguments that can be passed into a function. All right. Any questions so far? All right, let's talk a little bit about the script then. You'll see the first thing that we're doing here is installing packages. Now, R is open source and it allows anyone to develop packages that are sort of add-ons. So in other words, they create functions that do specialized things, and then they package them together and you add those into your library. And you can see in my list of packages, I have a lot of different packages, and that's basically extending the functionality of R. R has been around since the mid-90s, but it still has a really active and growing user base. And that's in large part because its functionality is always being extended and added onto. So, of course, today we're going to be using the R ORCID package. We're also using the tidyverse. Tidyverse is really a package of packages. And so it's like a set of several packages that do specific tasks well. So we'll be using tidyverse. We're not actually going to be use this in this particular session. We're going to be using anytime to convert some dates. We're going to be using janitor to clean up some column names. And we're going to be using glue, first of all, to paste together our query. All right. So again, if don't get too overly concerned with knowing all of that. I'm just giving you that context so you understand as we go along. So the first thing I'm going to do, I've already installed these packages. If you haven't, you should run through and install one by one, but they're very large. So it's going to take your, especially tidyverse, it's going to take your system quite a bit of time to install it. So now, after you install the packages, you have to load them into your session. And you have to do that every time you open up R as a way of, so it's already installed, but now you want to bring them in and make the functions available for use. So another shortcut you can do in R, if you've got a script, is you can highlight a chunk of code and you can press Control Enter or click on Run to run that entire chunk. All right, next thing is to authorize the ORCID API. In other words, to give your R session permission to query the ORCID database or registry. Now, ORCID underscore auth with open and close parentheses, this is a built-in function in our ORCID. And what happens when you run this is it will open up a browser and it will prompt you to log in with your ORCID credentials. Because I've already done this, I'm going to add in this argument so that it actually works for me. Let's see. Oh, I have mine stored. I'm sorry. I have mine stored in my R environment. So it's not actually going to demo this. I actually deleted it right before. Then I ran this and it got added in there again. And I forgot to delete it again. But essentially what's going to happen is it will open up a new browser window. You'll log in and then it will say, please close this window. And you can jump back into your RStudio session and it will give you this bearer, which effectively gives you the permission to query the ORCID registry. All right, now here in this next step, we're going to build out the query as Sheila described. And what we're going to do is we're going to take these different values and we're going to paste them all together to craft a custom ORCID query. Now, you'll see here this little figure, which is in R called an assignment operator. Now, you can assign any value to any kind of variable name, as long as that variable name does not already exist as a function in R. So for example, you wouldn't want to assign something to sum because sum is a pre-existing function in R. So when I run this, so I'm going to run this ringgold underscore ID gets 7618. 7618 is in quotes, which means it's going to come in as something called a character. And there's character, there's number, there's logical, true, false. These are different data types in R. So I'm going to run this one. And what's going to happen is now it's added over here into my environment, the number 7618, actually the character value 7618. And it's assigned to the name ringgold underscore ID. So I'm going to do the same thing for grid ID, email domain, and do make sure that you are adding in the @ sign for your email domain, and organization name. So now I've got those 4 character values stored in my R session, and I can now do things with those. And what I'm going to do is I'm going to glue them together in order to make a query that I can then send to the ORCID API to get some data back, right? And so what you see here is I'm going to go ahead and run this, and then we'll parse it out. So I ran my query, and now I'm going to type in the bottom here. I'm going to type in my underscore query. By the way, I pressed Control L to clear out that console, or you can click on this almost invisible broom in order to wipe out the stuff that's already there. All right, now this query is in something called Solar, which is a querying language based on Java that the ORCID API accepts. For those of you who are in libraries or do a lot of research, you'll recognize that these are, it's a Boolean query. And really it's just taking this exact text, then it's pulling in the ringgold ID, which I assigned over here. And then it's saying space or grid org ID. So we're saying the results that I get back should have either a ringgold ID of 7618 or a grid ID of this thing, or have the email domain star, you can see that I wrote the star up here, star@okstate.edu. And what that means is that any value before the @okstate.edu. One thing to note is that the vast majority, I think I saw on the ORCID website that 97% of ORCID profiles keep their emails private. So you're really not going to get a ton of results based on the email domain, but you might get some. So include that. Or affiliation organization name, Oklahoma State University. And one thing to point out here is that's different from the other ones is I added in a double quote. You can see that here right at the beginning and right at the end. And so that's going to look up the phrase, the exact phrase, Oklahoma State University. And that's going to look in any of the person's affiliations. So it could be in my employment, it could be in my education, it could be in a grant that I received. So it'll look in all of the ORCID sections, and if it finds the affiliation organization name Oklahoma State University, then it's going to include it in that set of results. So what we're doing here is we're trying to cast a wide net as possible, and then we'll go through based on those results, and we'll look at the employments and we'll filter from there. So the next step is to get the counts. How many people, how many profiles fit these parameters? Now I've already run this. This one doesn't take too long to run. When I run it, I see that, actually I haven't run this one, so let's go ahead and run it. And again, getting into the weeds here, but this is saying taking a function called attr attributes, then it is running the query. So the function is, the package is our ORCID. The two dots will link the package to the function. I'm sorry, I'm throwing out so much jargon here. Okay, ORCID is the function, and that's saying I want to use my query as the query, and ORCID is coming from the R ORCID package. I know that's probably very confusing. So let's see, do I need to go back to any of these questions, Sheila, in the chat?
No, we're good. You can full steam ahead.
Okay, great.
Yeah.
So again, this part is kind of optional. And the reason that I include it is just for clarity's sake, to show that the ORCID function is coming from the R ORCID library. This is also optional, saying that specifically I want to use the query argument to send my query to the ORCID registry. All right, right now though, if you've run this, you should get a value over here that gives you the count of profiles that match these parameters. So there's 2,142 IDs that fit one of these parameters. So the next thing that you want to do is construct a, you can only get back 200 at a time. So what we have to do next is create a value called my pages. And what this is going to do is it's going to start at 0. It's going to go to the ORCID count, which is 2,142, and it's going to jump by 200 each time. And all this is, so I ran that, and you can see over here, it's called my pages, is 0, 200, 400, 600, 800, all the way until, let's just put the whole thing, until 2000. And the reason for that is if there had been more than 2142. If there had been 2200, then there would be 2200 here. And we're going to use that and we're going to pass it into our query here to return 200 IDs at a time. All right, so that's kind of a ceiling that we can only get 200 results at once. So we have to kind of cycle through, and we do that by building a sequence of numbers, counting by 200 through the total number of items that we have. Okay, this next one is a little bit longer and a little bit more complex. What this one is doing is it's using a function called map, which sort of loops through whatever you tell it to, whatever you pass into it. So what this is going to be looping through is that sequence of numbers, 0 through 2000. And inside this function is where I have my query, which is actually right here. All right, so previously we ran this, but we just got the attribute, the number of found records. Now we're actually going to get the data, the ORCID IDs themselves. And so what we're doing is we're still using my query, which we created above, the Ringgold ID, grid ID. We're returning 200 rows at a time. We're starting with page. Now, page is kind of inside this little function that we've written. So it'll start off with 0, then it will put 200, then it'll put 400, and each time it'll return 200 results. So I hope that's not too confusing. The first set gets 0 through 200, the next set gets 201 through 400, and so on until we've got everything at once. So I have already run this, and so we'll take a look at what we get back. And we have here 11 items, which 0 through 1200 would, I'm sorry, 2000 plus 1. And within each one of these, we can see there is 3 value table. And let me look at one of those to show you what it looks like. I'm going to say view my underscore orchids, and I'm going to put in double brackets 1. And you can see the double brackets here for each one of these. This is, in our terminology, a set of lists. And so if I look at this first one here, we'll see that there are 200 rows here, which we would expect because that's what we asked for, 200 rows. And within each one has the ORCID identifier URI, which is the URL with the ORCID ID, and the ORCID identifier path, which is the ORCID ID itself. And then all of this is orcid.org, which was the host. So what I want to do next, though, is because these all exist in their own kind of independent lists, each of these are called tibbles. It's another word for kind of data frame or spreadsheet, you could say. I want to put these all into one thing. And the way that I do that is with this little function here. So we're now introducing a new symbol here, which is called the pipe operator. And what this does is it takes the output from this line and uses it as the input for the next line. So an example of that over here, just so we're clear, is I could say 4, and I could put in a pipe. Pipe comes from the tidyverse. So when you load tidyverse, you're able to use the pipe. It does not come with base R. So if I say 4, and then I want to use that as the input for my next line, and so I can say sum of whatever I fed in from the previous line, sum of 4, and let's say 4, and we have 8. All right, so it's basically a way of making the code more efficient instead of having to say, do this, then do this, then do this, and have kind of cluttering up your workspace with a lot of temporary values that you aren't really going to use. Using the pipe as a way of just tightening things up and doing it all at once. So here what we're doing is we're saying, take these, my ORCIDs, which is this kind of list of tibbles. Then I'm using another function. Don't worry about what this is doing. It's really just saying, put it all into one thing. And then clean up the column names. And so this clean names function will make everything lowercase. It will replace all punctuation with an underscore, and it just makes it easier to handle. If we look at the column names here, we see there's a hyphen, there's a period. That can get kind of unwieldy. So I like the clean names function because that streamlines it and replaces all punctuation with an underscore. So when I run that little bit, and you can just put your cursor at the end of it and press Control Enter or press Run, and it will run all 3 lines at once. Now, when I look over here, instead of having a list of 11 different data frames, I have one nice, neat looking data frame that's got 2,100 rows, which is what we would expect from that ATTR function we ran at the beginning. And it's got 3 variables. All right, so this represents the universe of potential current employees who are in the ORCID registry. So I want to show you something using myself as an example. So I'm going to take my ORCID ID. And there is a way that you can work with data in this RStudio environment. You can click on this filter here if you want to search for a specific value, or you can use this little search box up here, and that will search through everything. What I want to do is I want to search for my ORCID ID to make sure that I was included there. And indeed, here I am. And so how would it have found me? There's a few different ways. One is that I have made my email public. And you can see if I go in here, I don't have my previous university email public. So if I had searched for @UHCL, it wouldn't have found this one, but it found my current primary email address because that is public. It also would have picked up the exact phrase Oklahoma State University in my affiliation. And it also would have found my Ringgold ID. So those were 3 ways that it would have included me in that set of results. And the nice thing is that it's not duplicated. So it doesn't have 3 results for me. It just has the 1. I don't have a grid ID added. So if I had only searched by grid ID, I wouldn't have found me. That's why I said earlier, we're casting as wide a net as we possibly can. Okay, so to clear this search out, then I'm going to click on this little X, and that will give me my nice set. Now, where do we go? Okay, this will have returned anyone who had OSU listed in any of their affiliations. So this would have included students as well, or people who may have worked for OSU in the past. So now we want to start to hone this down and filter it. And that's where we're going next. Any questions?
I think we're good for now, Clark.
Okay. Now, we've just done, the only function from our ORCID that we have used so far is just ORCID, which searches everything, all of the indexed fields. I'm going to click on this packages tab here on the bottom, and I'm going to scroll down to our ORCID. I have a lot of packages installed. Okay. And this will show you all of the available functions in our ORCID. So it does a lot more than just a generic search, but you can search specific sections of someone's ORCID profile. So that's one of the huge values of this, this package. So you can search in someone's, for example, biographical data. You can search in someone's keywords. You can search in someone's peer review activity, their education, their works. So if they've added in their scholarship, you can search in there. What we're going to do, though, is we are going to search in their employment data, and we're going to use the function ORCID_employments. And you can see, as we saw in the sum function, it tells you what this function does and what arguments it takes. I want to note that the default data value type that comes back is in JSON, but you can also specify XML. And this will tell you here what the different formats of data that you can get back are. So if you're someone who's more comfortable working in XML, then in JSON, you can change this format to return XML. What I'm going to do here is I'm going to bring it back in JSON, and then I'm going to work with it in RStudio, the JSON file, using some of the tools that R has for working with JSON. But if you have other tools that you use to use JSON, then you don't have to use R. In other words, you can get the data back, and then you can open it up in a tool that you use to work with JSON. So, all right. Now what I'm going to do is this. All right. I'm going to create a new value called my employment. I'm going to use a function from the R ORCID package. And you can tell that because I'm using the 2 colons. The function is ORCID employments, what we've seen here. And the argument that I'm passing to it is this. I'm going to take from the my ORCID's data frame, and I'm going to use this $sign here to say, take the ORCID identifier path. Now, if we look up here, we can see that is this column. So basically, I'm saying take all of these ORCID IDs and one by one return the employment data for each one of them and return it to a value called my employment. Now, I've already done this because it actually doesn't take that long. It takes just a couple minutes for all 2,000 of these. So I already ran that, and that is up here under my employment, and we'll take a look at what comes back. So this time we have, for each individual ORCID ID, we have the employment data for that ID, and it's going to bring back all of the employment data for that person's ID. So for myself, for example, it's going to have Oklahoma State University Stillwater, but it's also going to have UH Clear Lake and UT Arlington. And that's, of course, because I've made both of those public. So, so we're going to have to refine this. This is not going to accurately represent everyone who is currently employed. Remember, that's our end goal. The other thing to notice here is that you can interact with this sort of like a JSON file. And where we get to the affiliations is under affiliation group and summaries. And so here you can see for each one of these values under summaries is a discrete record for employment. So for this first person, it's got Oklahoma State University, and it's also got the source for where this data came from. In this example, OSU is connected to a research information management system that writes their affiliation data to their record. So that's the source for this one, for example. So what our next task is going to be is to get, for each one of these, it's going to be to get all of these employment records. And that is this huge long thing. So we're going to go through this line by line. So the first thing to do is I'm going to create a new value called my employment data. And I'm going to call in the my employment value list that I just created. Then you can always think in your mind when you see the pipe operator, think of the term then. So I'm going to take my employment data, then I'm going to again use this function map, which is basically means it's going to go through each entry, all 2,142 list items, and it's going to pluck. This is another function. In other words, it's going to grab this data out of there. It's going to grab all data that is in the affiliation group, summaries. In other words, as we saw earlier, it's going to grab all of these for each person. And that map means it's going to loop through and do that for each person. Okay, then once it's done that, this is another one of those things that you don't really need to know, just know that it works. You don't always know how stuff works. Sometimes it's just enough to know that it works. But it's basically going to take all of that and it's going to flatten that into something nice and neat that we can work with. Then it's going to clean the names. Then it is going to clean up the dates. And this, I need to pause here and talk about the way that dates come back in the ORCID API is in something called Unix time, which is the number of seconds that have elapsed since 1977, January 1st, 1977, I think. So in the case of ORCID, it's actually the number of milliseconds that have elapsed since then. So the dates, unless you clean them up, are not going to make any sense unless you can calculate that on the fly. So we're going to use another function from another package called anytime in order to convert those into dates. So again, if you care about how this stuff works, that's what's going on. It's taking any date and it's dividing by 1,000. But it's suffice it to say that it'll convert your dates into something that you can understand. So I'm going to run that. And now we see up here my employment data. And we have 3,986 observations. And the reason for that is that people have multiple employment records. So there's not going to be 2142 because one person might have 1 or 2 or 3 or 4 employment records. So I'm going to go ahead and click on that. And you can see each one of these rows represents one of those employment records. Now, theoretically, I should be able to scroll over into my ORCID ID over here. And so each one of these, here are the ORCID IDs for that person. And you can see there's a lot of data here, and a lot of this data we don't really need because it's basically jumping over back into the internet browser. It's taking any potential value from here. So the start date, the end date, the position, the any of the associated Ringgold data, any URL that the person may have entered that's associated with this employment record, when it was added, when it was modified. So there's a lot of that data that you may not necessarily need, but it's going to give it to you, and which is good. You can get rid of it later if you don't need it. But you can see, and it breaks down each date into its month, day, and year if those were provided as well. So so there's a lot here, and it looks kind of overwhelming at first. But let's go back. Now, here's what I was talking about with that name value, where if the individual person entered in that record, then it will show their name. However, if your API or if your research information management API wrote that record into this person's profile, then it will show that value as the name. All right. Now let's come back here. The next thing that I do, this little chunk here, is just some column name cleaning. So there's a lot of columns that begin with this employment summary or source, organization disambiguated. So this just removes that and makes the column names kind of easier to handle. Any questions?
I'm not seeing any.
Okay. So, okay. Now, the next thing we need to do is take a look at the organization names and start to filter out the ones that are not associated with your organization. The way, one approach for doing this is to use this little chunk here. So what this does is we create a new value, my organizations. We take the data frame that we just created, this my employment data. Then with our pipe operator, I'm sorry, we're down here. Then we're going to group it together by the organization name value. So what that does is it will take every instance that says Oklahoma State University or Oklahoma State University Stillwater or Oklahoma State University Tulsa, and it will group those together. And then we're going to count how many of those appear for each one of those. And then we're going to sort it so that the most values come first. So when I do that and take a look at it, we can see, as we would have expected, Oklahoma State University Stillwater has the highest count with 598, followed by Oklahoma State University, then OSU Center for Health Sciences. Now we come to something interesting, and that is number 4 looks identical to number 2. So why wouldn't this one have been grouped together with number 2? The reason for that is, for those of you who do a lot of data cleaning may have suspected that there is a trailing white space at the end of this one. So it is in the system as a separate institution, at least that this recognizes it as something separate. So then A&M, which is actually something interesting, right? This is for further analysis, looks like A&M and OU, people who are employed at A&M, Texas A&M, or University of Oklahoma, or K-State, Mississippi State. All right, that's just kind of an interesting note. But what our objective here is to gather as many people who have OSU listed in their employment record. And the reason that doing this is helpful is because we can start to see those hand-entered anomalies. So, well, here's OSU Tulsa, which is not an anomaly. That's a separate OSU campus. So depending on what I'm interested in, do I want to include people who have OSU Tulsa as among their institutions or not? That's my decision. Here's OSU Oklahoma City, same deal. Now here's the Southeastern Oklahoma State University. That is not OSU. That's a separate institution entirely. So while it probably came up because it had that phrase, Oklahoma State University, it's not something that I would want to include in my final results. All right, so far so good, but now we start getting in, when we start moving down into the n equals 1, that's when we're going to start getting the messy stuff, where, let's keep going here. Okay, Oklahoma State University, comma, Stillwater. And there's a bunch more like that. I'm gonna actually scroll down all the way to the O's. Okay, here we go. So you look at all of these. Capitalization, CVM, that's Center for Veterinary Medicine or College of Veterinary Medicine, Spears School of Business. This Stillwater doesn't have an L. So remember, these are each discrete records that we would want to capture if we're trying to get as true and complete a set as we can from the employment records. So you have a choice here. You can either do manually clean up this column, which comes from my employment data right here, organization name. So if you know enough about data cleaning, you may use Open Refine, you might use R, you might want to transform any of these edge cases into something standard and filter from there. Or you can just go through and do it manually, and you can try and identify those yourself. I didn't include any scripts to do any of that cleanup, but I'm happy to talk about that. Or if any of you have experience doing something similar, I'd be interested in hearing from you. So one strategy for this is you can use the str detect function to look up entries that only include the organization name as Oklahoma. So my organization's filtered. That will include anything that has the word Oklahoma. And this can kind of help you to maybe identify those more easily. You may also want to do a lowercase o for Oklahoma, just in case, if you're trying to make sure you capture everything. And then the final step here is, this is probably not the most efficient way of filtering the final set of results. Actually, it would probably be better to pull, rather than do a copy paste like I did here, to pull directly from this my organization's data frame. But anyway, I didn't want to overcomplicate things. I don't know how successful I was with that, but what I'm doing now is I'm filtering that my employment data to only return those people who I've determined to be affiliated, or those records, I'm sorry, which should correlate to people that are affiliated with Oklahoma State University. So that will get my employment data filtered. And that's down to 1,071 records, discrete records, all right? Again, not necessarily individuals, but records, because you can see that it's still repeated. So then the final step is if we are looking for currently employed people. Now, there is no flag in ORCID that, or like checkbox that someone can check to say, I currently work here. So the only way to represent that is if they do not fill out any value in the end date. Then jumping back over into my profile, you can see I'm employed from 2018 to the present. It's because I didn't enter a value in the end date. So ORCID interprets that as being presently or currently employed. So looking back at our data, then there's a value for end date year value. Here we are. So end date year value, if there's no value in there, then what we're doing is interpreting it to be that that person is currently employed. As Sheila mentioned at the outset, that may not necessarily be a safe assumption. They could have not gone in and filled out their data. There's a few different reasons why that they may have never just filled it out in the first place. So, but it's a starting place. So if I run that filter, then I'm getting my employment data filtered current. These aren't really the best variable names, honestly. They're too long. You can just put X, or you can shorten these and make them simpler. I just wanted to put descriptive value names for just so you would kind of know what each one was. So now I'm down to 660 discrete records. Now most of these will be a lot of these, there will just one person will have one employment record for that institution. You're seeing doubles here for OSU because, as I mentioned, we have a research information management system, Elements, which writes affiliation data. So I think in a lot of cases, the person has put it in manually. Then when they integrated with our research information management system, it wrote it another one. So there are duplicates, or someone might have a duplicate because they might put a position where they were professor, and then they moved into an associate dean, and they had created a new record for that. So there may be some duplication here, but the important thing is getting the person's just having that record for that person. Now, where is their name? That is entering into another kind of sticky point of this data. Their name will exist in this name value, but what this name value pulls on is the name of who or what created that record. Okay, so OSU's Research Information Management System created this record, and so did John Riley. So there isn't actually a name value per se. And this piece of the puzzle is not included on the script that we gave you, but we'll give you another one that includes this little chunk. I'm sure that some of you heads are spinning already, but so I don't want to get too much more into the weeds, but you do have a complete set of ORCID paths, and you can then use you can take these ORCID paths, and jumping back over into our ORCID, you can run a function for ORCID person to collect the name data and any other biographical data if you want to get their bio statement or their external URLs, like if they have a Scopus ID that they've linked. There's a lot that can come back using the ORCID person function. But I think for the most part, if you filter out where ORCID URI is NA, which was included on your script, that will give you a good base set of people that will include their name values. And you can go from there. So I hope that last little bit didn't get too confusing. Does anyone have any questions? Yeah, Mark, good point with running trim WS, or there's also a function in string R. I think it's str trim that will get rid of white space. Yeah. Any more questions? I would like to talk about some applications for this. I'd be interested in hearing you. I can share what we have done with some of this data collection if you want. But does anyone want to chime in with anything? Okay. The way that one of the things that we've done with this is we've merged the resulting set of IDs to our HR data using fuzzy name searches, which means kind of like there are functions in R and in other places that will merge two data sets together if the name is similar within a set of a few characters, and there's all kinds of sophisticated algorithms that go into doing that. And then we've taken that and we've imported it into our research information management system as a way of harvesting publications. You could also harvest publications yourself. So for instance, if you're interested in where your faculty are publishing, maybe for doing some kind of collection analysis, or just as in a scholarly communications program. So you can take that resulting set of IDs But instead of putting it in ORCID person, which would get biographical data, you can then turn around and put it in ORCID works, which will return all of the scholarship, all of the scholarly works that that person has added into their record. And then you can do, you can maybe look at ISSNs if they've provided that, or journal names, that kind of thing. But that will, of course, only be if they've added their works into their ORCID record. So I do cover that, jumping over back into my walkthrough. Here at the bottom, getting works. So this is an example. You put in someone's ORCID ID. In this case, we would put in that whole column of ORCID IDs, and then do this little cleanup operation. And this gives us a journal title if provided. There's a lot of other stuff here, where the value came from, what the name of the article is, publication date, all of the associated metadata that you would expect. Let's see.
Hello.
Hi.
I want to say thank you. This is something I've been looking for a long time, but this is really great. Thank you so much. Do you guys have the membership API? Yeah, I was really proud for this. This is a good effort for this part. We don't have a general research management system yet, so I think this will be really great with this piece, and to integrate that for the publication for faculties, because to be honest, we're basically collecting faculty publication manually using like a Google form or Excel sheet. So it's really hard to do that, and not everyone submit their things. I think this will be wonderful if we can get like this. So my question is, do your institution have the membership API? With the membership API, is that be easy to handle these things? Just curious.
Everything that I've shown you can be done with the public API. And if you have the member API and you have added, the researcher has added you as a trusted organization through the authorization process, then you can potentially pull more data than they have made publicly available. So for instance, they may have certain works that they don't have listed as publicly available, but they say you're a trusted party, and you can harvest this data if you want to. But it's, most of this stuff, they do make it publicly available, so you don't have to have the member API. The other advantage of the member API is if they have associated themselves with you, then presumably they're a current employee, so you don't have to go through all of this acrobatics of trying to figure out who's affiliated.
Yeah, that's what I'm saying. The filter part might be easy. Just whoever trust as a trusted members, you just pull out that list.
Right.
Just thinking that might be easy, but we might miss people because they probably forgot to put us as a trusted parties. So there is the benefit, also have the cost on that part.
The ideal is, and our institution is not here, maybe someone else's is, when a new faculty member or researcher comes to the university, to provide their ORCID identifier, and then if you have an API, to have them add you as trusted, and then you do have hopefully a more accurate set of ORCID IDs.
Yeah, great. Thank you so much.
Thank you. Sheila, was there anything you wanted to add on to that?
No, I think you covered it. Somebody is asking though if this code is available on GitHub and can be forked, and what the reuse license is.
Yes. So all of the code is on my website, which is pulled from a GitHub repo, and you can do whatever you want with it. I'll put the direct link to the repo here in just a second.
Great. And while you're doing that, I'll just say thanks everyone for sticking around with us for this hour and a half. And like I said earlier, if any of this was a little maybe over your head, or if you have been trying to run these scripts and are running into errors, just contact me. I am more than happy to work one-on-one with people to get you set up to do it on your own, or I can run this for you. So just don't hesitate to contact me. I'm also seeing a question about how would you approach running this if there are multiple Ringgold IDs that apply to your employees, such as a university one and one for like a hospital. And I've seen this too, where like different units or departments on campus each have their own Ringgold ID. So yeah, that makes a lot of sense. So would you recommend running the script 2 different times and then combining the data at the end, or how you want to speak to maybe adding additional search terms?
Yeah, you could either do it that way, or you can add in another value here. So so you can say Ringgold ID 2 gets whatever that separate Ringgold ID. Then you would carefully add in another one of these to your query parameter. So, and I would want to add in or. Now, when I change my query, oh, I have to add this and then this. Now, when I look at my query, we can see I've got Ringgold org ID 7618 or Ringgold org ID 1234, or so any other parameters, or if you want to add in a fundref ID or a different email domain or a different organization affiliation, you can just keep adding those in with the or parameter.
Yeah, absolutely. And I actually ran one of these queries for an organization that definitely had a fundref ID that was showing up on a lot of people. So I added in the fundref, and also they have 2 different organization names that are both equally used, and so adding in a second one. So yeah, if you do have any situations where you're wanting to add more search terms, and maybe you're a little confused about how to do it, just contact me again. Let me know, because I'm more than happy to help. I'll put my email address one more time.
And there's also the documentation on the ORCID website, as well as on their GitHub, that has like the full set of arguments that it takes. So we only looked at a very small handful of those, but you know, there's a lot more there.
Yeah, absolutely. There's so much that you can do depending on what you're interested in. But I hope that this was a good intro to R, and getting you a little bit oriented about how you can use R to work with the ORCID API. And thank you so much, Clark, for putting all of your time and effort into this and then sharing it with us. Big round of applause for Clark, everyone. Yay, thank you.
No, I appreciate the opportunity. I hope I didn't go too fast, too much, but I appreciate all of y'all sticking with us.
Yeah, absolutely. And I will be sending out a link to this recording, to the notes and all of the links that were included there. And also the additional part of the script that includes, that makes sure it's getting the names and the biographical information that we just added in. So stay tuned for all of that. Great. Thanks, everyone. Let's see. Can I comment if there is an equivalent Python library? I don't know, but I could find out. Anna Cardoso, do you know?
No,
if there is
we
a
need to get
Python?
to the developers, so no, sorry, Sheila,
Okay.
not sure.
Okay, we'll double check on the Python question, Mark and Laura. So stay tuned for that. But yeah, I've got a copy of the chat, so I'll get back to y'all that had questions. But I think with that, we have reached our time limit. So thanks again, Clark and everyone. And just keep in touch with me as questions come up. I'm more than happy to help.
Thanks, everyone.
Yay, thank you all. Have a great rest of your day. Have a good week. Talk to you later.
Bye.
Bye.
I don't know about you, Clark, but OU shut down for tomorrow.
Bye, Sheila. Thank you.
Oh, bye. It looks like Clark dropped off. Stay safe
Yeah.
and warm, everyone. All right, I'm going to end it.